Alright guys, we're going to be solving question 23 from the second chapter of Mechanics of Materials by Johnston. And in this one we have members A, B, and B, C that are made of steel. So we have the elastic modulus for each of these members, and we have also the cross-sectional areas of 0.8 inches squared and 0.64 inches squared for A, B, and B, C. And we need to determine the elongation of member AB and member BC. So we solved a couple of questions in this channel in the previous videos. If we want to find the elongation, we simply have this formula: force times the length of that member over elastic modulus times the area. And as long as we can figure out the force in each of these members, the rest of this is pretty easy. So we are interested in these two members, AB and BC. So for finding the AB, we can use the method of joints. And if we just draw the free body diagram for joint A, we should be able to find all the forces that we have in here. So we have 28 kips downward. We have these two members here. And if we just want to find the correct direction for each of these, we know that FAB is the one that has Y component. We just show our X and Y in here. Since we have a force downward, AB has to be in this direction to have an upward Y component, and now we have one X component to the right from FAB, which means FAD has to be in this direction. And we're going to use our equilibrium equation, sum of all forces in Y equals 0. We have the same thing for X, but since here we are interested in FAB, we're going to do sum of all forces in Y, and for that we need to figure out some information or the angle that we have in here. If we look at this right triangle that I'm highlighting in green, we have 6 feet here, 5 in here, and if you just want to find the hypotenuse, we simply have the Pythagorean theorem, 6 squared plus 5 squared, and if we just calculate that, we're going to have the square root of 6 squared plus 5 squared, that's going to be 7.81. So if we want to find the y component, we're going to have FAB times, we just call this angle alpha, sine of alpha, which would be this angle here. So opposite 5 over the hypotenuse, 7.81 minus 28 equals 0, again because of the equilibrium, sum of all forces has to be equal to 0, and we can find FAB here. Easy, 28 times 7.81 divided by 5 times 28 divided by 5. That's going to give us 43.74 kips. And if we just want to report it as pounds, we know 1 kip is equal to 1,000 pounds. So this will be 43.74 times 1,000. That's going to give us the 14 pound. We can just find the elongation that we have in here. One thing to keep in mind is that the member AB, which would be somewhere in here, would be in tension. So the force has to be in the opposite direction of what we have at the joint. So the member would be in tension, and if it's in tension, the elongation has to be positive because it will be elongated. So that's going to give us the force in AB, which we found 43.74. And we're going to go with the pound because the unit that we have for elastic modulus is psi, or pound per inch squared. So that's why we have to do the unit conversion in here. So the length of AB we figured out is 7.81, is basically the hypotenuse of that right triangle. And the elastic modulus 29 times 10 to the 9, 10 to the 6. And the area of the AB we have in the question 0.8 inches squared. All right, one thing I forgot to do in here, we have all the dimensions in feet, and since here we are dealing with inches squared for the elastic modulus, we have to do a unit conversion for inch as well. So we're going to multiply this by 12, that way we're going to get it in inches. So I almost forgot that unit conversion. So let's calculate what we get. So 43.74 times 7.81 times 12 over, got 1,000 in here, over 29 times 10 to the 6 times 0.8, and this is going to give us 0.1 0.177 inches as for the answer for AB. And now we have to find the forcing member BC. Now that we have the AB, we can just move on to joint B. So for that joint, we have three members connected to that joint. One of them would be what we had for AB. Again, the member would be in here. This is the force from the joint to the member. The force from the member to the joint would be in this direction. So this would be our FAB. We have to watch for these directions as we go along. We discussed all of these in the other channel for engineering mechanics on how to analyze the trusses. So I'm going very quick in here, but feel free to check out the other channel if you need more examples and more questions. So here we have Y component downward from FAB. This will be upward. So the other member would be FBD. And this has to be to the right, which would be FBC to cancel out the X component of FAB. So we can see that this angle is also alpha. So we're going to have the same scenario here to alpha. Since we are interested in BC, we're going to do sum of all forces in X in here. We have FBC minus FAB, this time cosine of alpha. So FBC would be FAB, which we found was 43.74. I'm just going to do the unit conversion for pound. That way we can get FBC in pounds too. And cosine of alpha, if we look at the angle alpha, cosine of alpha this time is 6 over 7.81, or the adjacent over hypotenuse. So times 6 over 7.81. And let's see what we get for FBC. So 43.74 times 1000 times 6 divided by 7.81, 603.7, and we're gonna have the same formula for the elongation FBC. And this one's also the member BC in here would be in tension. So we're gonna have another positive elongation for this one too. So no need to put a negative sign. If you just by mistake assume that FBC is in this direction at the beginning, you're gonna get a negative sign at the end that shows the actual direction was to the right. But you have to keep in mind that you don't consider that negative sign in here, because that's gonna give you wrong elongation. So always figure out if the member is in tension or compression and go from there for elongation, and if it's positive or it's negative. So the force is 3,603.07 times the length of BC here. It would be 6 feet. Again, we're going to multiply it by 12 to get it in inches. We're going to have same elastic modulus. Again, I go to 10 to the 9. And the area is in the question. It will be 0.64. And this should give us the final answer. Let's see what we get. And yeah, this is going to be 0.13 inches. And this is going to be the answer for this question. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.